All right. Well, welcome everyone. Very nice to have you here at Aiven. My name is Andra. I work at Aiven. We're in the Aiven office right now. I run our startup program here at Aiven, but tonight is not about us. It's about all of you and about all of the awesome talks that we're going to have in a second. But before we get there, I just want to give you a quick intro to what Aiven is, what we do. So you have an idea. Well, we are data infrastructure platform. We offer 11 different open source data services that you can deploy on any cloud. We manage that on behalf of our customers. We work with large customers like Volt, like Decathlon. We also support startups, but you can also get started with some very small plans if you're interested to test out the platform. You can experiment with free Postgres, MySQL, or Redis for free forever on a very small plan. But you can also have a look at our website to see what other services we offer and what else you might want to do with them. We also have a community forum where we try to encourage discussion. We have really cool docs, so you can feel free to check out all of these links to learn more about us. And as I said, I run the startup program. So if anybody here works in a startup or knows somebody working in a startup, you should know that we offer up to $100,000 in credits through our startup program for startups to spend on Aiven for a year. It's a really big support for companies in the really early stages. We really try to take away the burden of paying for infrastructure from them and to help them grow. So again, only relevant if you're in the startup world. We run our own meetups as well. I won't go into that too much, but this is an event we're hosting in London on the 12th of December. Obviously, we're in Helsinki right now, but if any of you happen to be in London, this is a free event that we're running. It should be really interesting, about half a day. So feel free to check it out or share it with people in London if you think that's something interesting. And then the last thing I'll say before we go to the talks is that we are at an Aiven event or in an Aiven office, and we adhere to our code of conduct. Essentially, what that means is that we don't tolerate any behavior that's not all right. So if you feel like anything makes you uncomfortable, if you notice anything uncomfortable, feel free to reach out to me. This is the basic: no racism, no sexism. We're all inclusive and mindful of each other. So please keep that in mind. And I think we'll keep this one for later. I'm going to stop here. I'm going to give it over to Ronnie, and then we'll start with the talks.
Thank you. So a bit of introduction of myself. So my name is Ronnie Salovara. I represent the PingCAP. I'm the sales guy, most likely the only one in this meetup, but nonetheless, thank you for everyone of being here. And we have 3 different speakers. We have Irori, we have Bolt, and we have PingCAP. So this meetup is all about the databases. So it's gonna take, I would say, few hours and lots of interesting talks. And also we have some free merch. There are lots of socks, there are t-shirts, there are cookies from Amsterdam, legal cookies from Amsterdam as well, and so on. So once again, thank you for being here. I think this is 5th or 6th meetup that we host together with Aiven. We have done one in Singapore, Berlin, Amsterdam, twice in Helsinki. So thanks for the Aiven team also helping us. So yeah, that's everything from my side. So now I would like to hand over to Mattias Jonsson to deliver the first speech. Thank you.
Okay, yeah, so I'm going to talk a bit about TiDB and upgrading or migrating to TiDB from MySQL, MariaDB. And I will just use MySQL It includes MySQL, MariaDB, RDS MySQL, RDS Aurora, MySQL, etc. So if I say MySQL, you can more or less assume I also mean the others as well. We're an American company, so I need to show this. I actually come back a bit to this statement later. A bit about me. I'm Mattias Jonsson. I'm working at PingCAP as a senior database engineer. I've been at PingCAP for about 2.5 years now, working on the TiDB server node. So I'm mostly coding in Go when I'm not helping out with meetups and so on. Previously, I were at Booking.com as a senior developer and later on an engineering manager. When I left, I had 2 of the 3 MySQL teams, so I know a bit about managing people and managing MySQL at scale as well. And before that, I worked as a senior software engineer at MySQL, Sun, Oracle. So I was working with the server code there, mostly with the table partitioning. A bit about PingCAP. It's the company behind TiDB. It was founded in 2015. It's a global company. It has offices a bit here and there in Silicon Valley, in Sunnyvale, Amsterdam, where I work from. We have Tokyo, Beijing, Shanghai, Singapore, and other places as well. It's a very strong open source culture in the company. Already when it started with open source and put it in on the GitHub, etc. So it's easy to follow the development, etc. All the issues are in GitHub, and everything I push directly to GitHub for a pull request, etc. Reviewing is done there as well, so it's easy to follow. We have strong investors. I think at least 2 years ago, we were already up in the D+ round for $500 million in total, I think. So we're here to stay, and we're a bit more than 500 people. And TiDB, that's what I'm going to talk about. It's a distributed SQL database. If you know MySQL, it looks just like a MySQL primary. You don't need to think about any replication or anything like that. The SQL syntax should be the same, etc. Using the same connectors. Scaling, though, is as easy to just add more nodes. So if you need more connection, you can add more SQL processing nodes. If you need more storage or more I/O, etc., you can add storage nodes, and it just scales both the size and the I/O for that. You can deploy it just as you want. We do provide a database as a service, both a dedicated tier as well as a serverless. The serverless is pay-as-you-go. There's also a free tier there if you want to just try it and see how it works. But since it's open source, you can deploy it in your own cloud or on-prem as you want. You can use Kubernetes, or you can use our tooling for deploying it as well. We have a TiDB Kubernetes operator as well, yes. So our own database as a service, we actually run that under Kubernetes, but quite a few customers are using TiUp. It's a utility for actually deploying it on VMs or bare metal even, etc. And as a developer, I use TiUp all the time for testing various things because it's super easy to spin up a whole cluster. It's just a single command. Yeah, that's easy as well. We do have an optional analytics, a column store. That's the TiFlash. And I won't go into that more here, but since the column store, it's easy to do scanning, etc. For a single column. So that can offload the more row, the more transactional engine in TiKV. We have migration tools, and that's what I'm going to talk more about. And we also have a change data capture. So you can stream all the changes to Kafka or actually apply it on another MySQL or TiDB cluster. The difference between an SQL that's distributed and a traditional SQL, it's first of all, it's built for the cloud. What does that mean? Well, you can compare a bit like monolith versus microservices in the design. Normally, it integrates really well with Kubernetes if it's something that's distributed nowadays. High availability, it's built in. The design is to be high available. So you can pull out any part of it, and it will just continue to work. That means better uptime in time. Scalability, that's by design. You can just add more resources and it will scale and use those. You can more or less see some of the design as you have coordinators and workers, so that's how you can balance it as well. And it means parallel execution. In our part, it's parallel even for a single query. So compared to MySQL derivatives, it has just a single thread normally to execute a full single query. It's a completely different optimizer and executor in the implementation. A lot of the theory is the same though. That means that the performance characteristics are different. The single instance is usually faster if you only have a single key lookups, while if you're doing something either more bandwidth or you need more complex, then the distributed system is usually faster. The traditional is actually a single writer. I saw that Amazon just released an unlimited or limited less Aurora. That's still a single writer and multiple readers. So even if it sounds like it should be scalable, it actually is not scaled for writes. Then they say they can do sharding instead. And SQL that's distributed, it doesn't need sharding. It's built in, it's designed to scale size-wise and operational-wise. In a traditional one, you need to shard. So that means that you need to split even tables. So you can say that in this range or like odd numbers goes to this instance and even numbers goes to that one. But it means that you have two different systems and you can't even do normal SQL like select from a single table any longer.
Is there some way that you can tell that, okay, this is the way I want to shard?
It shards, it distributes by ranges, but it means that it doesn't take the full range of a table. It takes the range for the data that is there. So the table data is in one kind of range, but indexes are a different range.
They're like always by primary key or some other key.
So it's the key. I can come back to that a bit later. So the different components, there's three major components. It's the TiDB SQL layer, it's the storage layer, and it's the metadata and management part, more or less. The TiDB server, okay, it's a bit confusing. You have a component that's named the same as the cluster, but this is the one that handles the SQL layer. It has implemented the MySQL protocol. It's a newly implementation written in Golang. So it has the protocol and it has, supports the MySQL dialect of SQL as well. And it has a newly written optimizer and executor as well. And this node type is completely stateless. So it's super fast to just add more, to scale it out, as well as scale it in. Then we do have the storage cluster, and the main part there is TiKV. And Ti in all this abbreviation, it actually stands for titanium, so that's why we're using it. It actually was a CNCF project that's now graduated, so that's why you actually find that under the TiKV repository instead of a PingCAP repository. We map relational data to a key value store, so and that's actually how you do the ranges as well. So it depends on the primary key or the key if you're having a secondary index, etc. And we group this into 100 megabytes ranges. And each of these ranges forms a raft group, and this raft group makes sure that this data range is replicated and kept in sync over the different availability zones. The physical storage of this is RocksDB. So you can basically see the different parts of TiKV here, that the physical storage is RocksDB. It uses raft for keeping it in sync. You have a transaction layer. You have an API for just key value store. So it's just point queries more or less. But we do have a coprocessor API as well, which means that you can push down functions and filters, etc., down to TiKV. So you don't need to send all the rows back to TiDB. So it's much more efficient that way. And the last part, it's the placement driver. It has a couple of different functions. The main one is to be a timestamp oracle. It gives timestamps for the multi-version concurrency control systems or transactions. It has some cluster metadata, and the name comes from it has the placement drivers. It places the data. So it balances everything on the TiKV nodes. It first of all makes sure that high availability is guaranteed. So it will make sure that the copies are spread among the availability zones, or if you do it on-prem between different racks, for example. So that all depends, even on an on-prem solution, you have the HA built in there. It also splits and moves data ranges between nodes. It does it by size, of course, so splitting and merging, but it also does that on load, both for reads and writes. So the result here is that the whole storage cluster is very well balanced because it's actively doing this scheduling of the different data regions. Always keeping HA up to date, and then make sure that size is balanced and load is balanced as well. So just going back to why you would use TiDB then. For your application, there should not be any changes. We worked really hard in being MySQL compatible. Scale, that's as just simple as adding more nodes. Then you get more CPU, you get more IO, you get more disk, etc. You can also use it for consolidation. If you have lots of smaller instances that start to be hard to manage because it's spread over, or you don't have automation for it, for example, then TiDB is a good use. We do rolling upgrades, so the whole cluster is alive during upgrades, which means there's no downtime. We offer an option of real-time analytics, so you can run analytics queries actually in the same transaction even, but there's no delay from the normal OLTP, so the transaction system, to the analytics system, because it's all the same data. It's kept in sync between the row and the column store. You can deploy it as you want, and you even have a pay-per-use version, the TiDB serverless, where we have done some other optimizations. So that's a multi-tenant system, so you can start even with a free tier and go up to terabytes of data, where we push cold data into an object store like S3, for example. So the toolbox for migration, it's 3 major components. We have it in different products as well as an integrated part. We have dumpling that does a parallel logical dump from MySQL derivative. We have lightning that's importing, and this is a specific tool. It's not just an efficient insert into. It actually writes the SST files, so the log structured merge tree files in RocksDB, and serves the files directly to RocksDB. So it bypasses the whole SQL system and makes it really efficient and fast. It also does the same for creating indexes. So not just row by row access or row by row writes. And then we have a full package called data migration. It uses both the code for dumpling and lightning, and it also can stream the bin logs and apply the bin logs to the TiDB cluster. So using that, it's just to set the cluster up, which is, I will show you how to do that. And then it will copy the data from a MySQL server and keep it up to date through the bin log. So in the end, you will have them both in sync online. We're releasing a new version soon, but the latest development release includes import from. So it's a new SQL command that you can actually use the Lightning way of importing a lot of data. And that also supports S3, for example, and Parquet files as well. And we have some tool for checking differences between 2 different instances. DM, so the data migration tool, it's actually a cluster by itself. So it has master nodes and worker nodes. If you want, you can just have a single master and a single worker that works. But if you're doing a bit of bigger migration, if something breaks, you probably want to have a bit of redundancy. So it's built for being high available as well. It even have some monitoring and alerting, etc., through Prometheus and Grafana. So it just dumps the data, loads it, reads the binary log, and applies it, and we're done. It's up to you then to choose when the application should switch to TiDB instead of the MySQL installation. It's basically just a few commands to set up, and you need to check the YAML files for setting up the different servers and login and so on. So you can just start by creating a template. Then you can use that template, which just defines which machines should be in the DM, so the DM masters and the DM workers. And then you select which version you want for this, all by this tie-up command. This tie-up is the same as you can use for deploying a full cluster or just a playground cluster in your own laptop or anything like that. Then you deploy it, you start it, and then you configure a source. Where should I read all the data from? And then you create a task and start the migration. And in the task, that's where you define where it should actually, which TiDB cluster it should write to. You can also use Kubernetes or just start them manually as well. But we do have tools for use at the bigger scale where TiDB really shines. So a cluster YAML file, it's very simple. You have some global variables. You can have a config on more of a server level. You list the masters, you list the workers. You can add monitoring and alerting as well if you want. The source, also very simple. You name it and you just define from where it should read the data. Of course, the source needs to be set up so you have a user that actually can do both reading the data as well as doing replication. And then the migration task, it's similar. You say which source it should use and where it should, what the target is. You can do some other filtering and so on. This is just an example where I used the sysbench for migrating it while it was running, so it worked well. You can do it in other ways as well. Loading the data manually or through Lightning. That can be very beneficial if you're doing from migration from Postgres, for example, where we don't connect and read the data because it's a completely different setup. Usually people that writing their own applications and so on have a good control of that. They would do a double write, so they will already, when they're doing writes, they will see if there's any differences between the original MySQL source as the TiDB target. And usually, moving a lot of data, you want some kind of safety net. So you want to compare the data. DM actually has a continuous verification you can configure. Otherwise, we have tools for called sync diff inspector. You would run application tests, I really hope. Benchmark it probably. We allow streaming changes back to MySQL or MariaDB as well with TiCDC, so the change data capture. That's also built as a cluster, so you can have that high available as well. And all this allows fallback in case you switched over to TiDB and all of a sudden you see something that never showed up in testing or anything like that. So always good to feel a bit more safe and have multiple options to back out. When you switch over, I would probably just change the order of it first and continue double write to MySQL while moving on to TiDB, and then eventually remove the double write, etc. We have some extra features as well. If you already sharded your MySQL system, then you can actually merge all those shards back to a single table again and have the full functionality of SQL again. It's also aware of online schema changes by PTOSC or Ghost. So instead of copying all the data and having double writes through the bin log, it can actually filter out that and running an online DDL instead. Compatibility between TiDB and MySQL, it's a newly written system, so it doesn't support everything in MySQL. So there are some compatibility issues. Special and GIS data, that's nothing that's supported yet. We don't do storage procedures, triggers, functions, and events. There's some syntax that's not supported yet, especially from MariaDB, the returning option in insert, update, delete. MySQL doesn't support that, so we never did that. There's some DDLs that are not supported. For example, you cannot add or drop a clustered primary key. Auto increments are slightly different. You can configure it as you want. But the default is that each TiDB node would cache like 30,000 IDs or so. So if you're inserting to multiple TiDB nodes at the same time, it might be that you get number 1, then 30,001, 2, etc. So they might interleave a bit. That's something to be aware of. Yeah.
When you do multi-row insert,
yeah,
you want to return, you have like a return.
No, it's the same last insert ID, I think it is.
Because let's say like regular, let's say on MySQL MariaDB, if you load the insert, then it basically it gives you the first auto increment ID. But now when you, let's say you insert like thousands of rows at once.
Yeah.
And is there a way to return the all the auto increment?
No, it's similar as MySQL. And is it the first auto increment ID or the last one?
First, I think. First,
I don't know. Yeah, you're probably right.
Regularly, old systems, it basically promises them to be.
Yeah. So if it crosses the batch barrier, then it will be a big gap there.
Yeah, it's not a same problem, but actually, as MariaDB has like the ability to return there.
Yeah.
Insert.
Yeah. So we don't support that yet. Yeah, we're aware of we don't support it yet, but that's something that might actually be interesting for us as well.
I would think that actually the whole transaction would be critical one that so you actually can calculate all IDs of your insert flow.
Yeah, but if it crosses the cached barrier, then it might be different. But in normal cases, you should have a consecutive batch number there. Character sets, we just recently added the support for the default MySQL 8 collation, which is the UTF-8 and before 0900 AI, well, accent insensitive and case insensitive collation. So from 7.4, TiDB 7.4, we actually are claiming MySQL 8 compatibility. Sorry?
There's nothing but support or
So we store everything. We store everything as UTF-8 anyway. We can pretend it's Latin 1, etc. The picture first with the safe harbor statement that more applies to Ronnie. I'm a developer and we're completely open source. So release 7.5, that's already on GitHub. You can use it, you can compile it, you can run it yourself. So you can see everything that's there. He can't tell when it's released. I can say it's already there. The new part there is that we're claiming MySQL 8.0 compatibility. We have added some enhancement like the import intro that I mentioned. You can now specify which TiDB node to execute some DDL statements. So you can provision more TiDB nodes just for the DDL, so you can make sure that it doesn't impact production use. In the same way, we added pause and resume DDL functionality. So if you have a long-running DDL, you can actually pause it if you have like some bigger load on the production system. I just, well, in 7.4, I added the add and remove table partitioning. Table partition was supported before, but you couldn't move between a non-partition and a partition table without rebuilding the table fully. There's more optimizer hints and, of course, more performance enhancements and bug fixes. And I think that was quite on time for my 30 minutes. So any questions, we can take it here. And otherwise, just contact me or Daniel or Ronnie, for example. Yeah.
About transaction support, let's say that you can do transaction multiple nodes. The probability of course, the transaction fail rate would give you like in Galera.
Yeah, so we do, the first implementation was an optimistic transaction model, which basically you did whatever you wanted and then you did the commit. But that, of course, sometimes it fails, which means that it's very confusing for someone that used InnoDB before, where you get the error while you're doing changes to the row. So we added a pessimistic mode that's been the default since long now, which also takes the lock as you use it, as you touch the rows.
So there's no need like a Galera has this like a, let's say that you do and you still get like an error when you are doing like a, let's say, one statement transaction. Like Galera, when it's optimistic, it tries again out.
I think for the optimistic, it might retry, but it's, I don't know. I need to check that in that case. So. Yeah, because that's basically what most MySQL, well, applications that use MySQL are used to. So to be as compatible with that as possible, that's why we have pessimistic as default. Yeah, you. I mean, you can create the transactions that will deadlock each other. Yeah. Repeatable read, right? I think. No, having a serializable in a distributed environment, that can never be more performant. Because then you really need to lock everything, so you actually do have the, especially the read serializable isolation level. Yeah. So we want to be as compatible by default as possible. Yeah.
If you have a small tables, not easy table, I consider that.
Yep. Yes, we actually do have cached tables as well.
Okay. Bigger table, but
I'm not sure. I think we actually do have a size limit of that. I can't remember. Yeah, so it's kind of read-only. What it does is that it caches it and takes a time-based lock. So when you want to write to that table, it needs to wait for that lock to expire, and then the write goes in, and then they recache the table. It goes to the TiDB nodes, so the SQL nodes. So it reads out the data from the storage and caches it in memory. Yeah, kind of. Yeah, so it's just distributed since we do keep the data in this 100 megabyte data ranges. And that's Daniel, by the way, that's my colleague at PingCAP. And we also have a Carrie here and Ronnie as already. So if you have any questions, feel free to reach out to us. Okay, thank you.
Thank you, Mattias. And the next speak will be from Bolt. So please take your time to set up the slides.
Yeah, I will tell a few words as introduction. Yeah, my name is Boris, and I'm engineering manager at Bolt. And we have been running TiDB in production for 2 years already. There was some issues, and we actually participate like a lot of meetups together with PingCAP. By the way, Aiven, like big thanks for hosting this meetup today. It's very nice place to be here. But today, our speech from Bolt is a bit different because usually we talk about infrastructure, about database itself, how to migrate data, how to keep it up and running. But today we have like a special presenter, which is actually did migration from MySQL to TiDB from application side. Like Maxim is developer, and today he will tell us like how migration looks from a developer's point of view. Yeah, thank you.
Thanks, Boris. Hello, everyone. My name is Max. I work for Bolt for more than 3 years, and yes, I'm a developer. I will not talk about a lot of DB, SRE, complicated stuff. I will rather talk about how we applied TiDB for our needs and what was our experience during the migration. So how I will talk about it, I will try to form it in a way that we have a timescale for the migration. We start with something and then move on, like from the minutes after migration, then to weeks after migrations. And I will tell how we managed to handle some of the problems we had and how we did not manage to handle some of the problems we had. Bolt is a big company. I guess it's present in Finland. A lot of people know it, but in case if you don't, it operates with the 5 core products. The most famous one, of course, is rights. That's a lot of information, but from the engineering perspective, what does it mean? It means that we utilize databases a lot for completely different scenarios. Myself, I work in the commerce department. I do backend for payments procedures. What I did, I was participating in migration of actually 2 databases. One was MySQL, and we were reaching the limits of MySQL. And another one was a thing called Vitess, which is effectively sharding stuff over the MySQL. And our databases are pretty large. We utilize around 20 terabytes in life. We do 20K queries per second, which is also has different data usage patterns. So we're not doing a lot of selects, updates. Also, one important reminder there is that what I'm talking about is the experience of migration to the version v6.1 of TiDB. And since then, a lot of changes has happened. So some of the problems we met could be not important at the moment. They might be already solved. So before the migration, what did we do? Well, we were running some performance tests. using the MySQL versus TiDB with some tests trying to replicate the how do we operate with data in life. And we were trying to do it pretty fast, and we weren't super cautious about it. So we managed to get some results, and we find out that the VTIS and TiDB, if we give somehow comparable hardware cluster, it runs almost the same. We don't have such a big difference, and it look like we are safe to go to proceed with the migration. In fact, it wasn't that good. And day X, we were sitting in one room doing the actual switch from MySQL to TiDB. And after the migration, just after the migration, the first seconds, we started to have problems with heavy queries, which weren't running good. And fortunately, it was solved pretty easily by the simplest hint to use the particular index. And then a bit later, we also added this line, which I absolutely love, but which in fact helped us a lot. Nevertheless, the final query was still slow, but at least we were live. And then several minutes passed. I had my coffee, was a bit relaxed. However, the cluster was still in vulnerable state. So we had a lot of unoptimized queries, and TiDB decided to use inefficient query plan, and the system was really vulnerable. And then, like, what could happen? One of our payment service provider may go down in several minutes after we performed the migration. So it looked like trouble just after migration, but then it became much worse. In fact, what happened after the permanent service provider failed, system tried to recover itself to finish all the payments which were started. We need to capture them. We need to get money from our orders. And it started to spiral. So we had a lot of retries hitting our database, which in an optimal state, with all the stuff being not optimized yet. So in order to handle that, we had to urgently add optimizations. And this is another line I love here. Please take a look. What's actually happened there? We have a condition which can utilize a good index, but it decided to utilize bad index. And using this weird syntax, we are making the planner to decide not to use the bad index and use the good one instead. So this is how stuff after the payment service provider outage was mitigated. But nevertheless, that's a lot, around 2 hours. So we weren't like 100% down. Some payments were going through, but nevertheless, it was a major incident. So then once the incident is over, there are still a lot of unoptimized queries, which are apparently not planned by TiDB to use the proper index. So we started with the simplest instruction to use index, like many of us did many times. And then what I was surprised with is that TiDB actually has a lot of special hints for situations with joins, with inefficient joins. And what I'm trying to offer everyone who tries to do the migration is to get to know many of them before you start the migration. So if you have to, like, in the state of emergency, if you have to optimize something, you would be familiar with that, and it would take less time than it took for us. So there is another fine optimization which you can use. I wouldn't stop on each of them because they basically, you can go to the page and like read about them in more details. And okay, we survived the day of our migration, but what we've noticed is that like our overall performance for clients which call us decreased a lot. Like here you can like observe that on average, it became like 2 or 3 times lower. So we had to deal with that. And what we noticed is that for the cases when we have a lot of concurrent operations, things are getting slow. So here is an example. Let's say we have a text driver and we have an order which just finished. We want to collect money, so here's a single request to like collect money. It's associated with some operation on database. Here's another request from payment service provider, which says we collected money, we also need to access database. Here we have fraud detection, which also need to get data online to perform its operation, And here we have accounting, which wants to distribute the money. And having all of that with all the possible like combination of it, it's pretty hard to tackle. So started to tackle it one by one, like finding which pieces of code trying to access the rows with locks. And the first idea which comes to mind, like, okay, we can do some optimization, find the difficult solutions for something, but maybe the easiest way to handle at least a part of concurrent requests is not make them not concurrent. And like what I've come with is for some parts of requests, I just delay them a bit using the SQS delay. And it helped in the sense that part of slow queries were gone with the 5 minutes of my effort. But that wasn't enough. We had to go forward with what is left. And here on the slide, you can see that like due to our technical depth, we didn't think about the possible concurrent issues when we were like deploying our code. And we, after the migration to TiDB, possibly due to the different timing of queries, we started to notice it. And what we have here is pretty much how the deadlock attempt looks like on a paper. And what we can do with that, we can reorder the query to avoid it, and it helped, and performance improved. But it's not all about the possible concurrent issues. Also, we have a system called Ledger, which calculates balances. And how it does, it consumes a lot of events from SNS SQS and tries to calculate the new balance. And to do it, it needs a lock on a row. And it happens that these events, like with operations over this row, they come in a batch with a very tight timing. So a lot of requests wants to get the particular lock on row. And how and here, like the error which you may observe in such case looks pretty bad, destroys our alerting, spams us, decreases performance, not good. And what we come up is to use external lock based on Redis to solve such things. It also helped us to utilize to improve the business logic. So like the overall result was good because we also optimized the procedure of calculating the balance, and we've decided not to calculate it each time the new transaction happened. But we didn't manage to solve all the issues we had. And here is how our DB warnings Grafana looks like. It has some random spikes for all schemas in our clusters. And here, like how it looks from the slow queries perspective, we have a lot of completely different queries which do not correlate one with each other, and we need to deal with that as well. So I've started to dig into TiDB monitoring, and started to look over the documentation of TiDB, because in the documentation of TiDB you can see some possible pain points which you can meet and some recommendations on how to solve it. So I took a look into some of the monitoring graphs provided by TiDB, and I've seen such the pattern which actually correlates to the problem described here on this website. The problem is called read-write lock. So I think like it's pretty descriptive, the title, what does it mean? But on the other hand, like here is how the proposed solution looks like on the web page. It effectively consists of where you can look for possible root cause, but we tried to do it and it did not help us. And it also like, we don't know what to do with that. Like it's called read-write lock because it's like, sounds like it's about a particular error, a particular query. But in fact, what we saw there is that we have all the queries in clusters being slow. So it looks pretty weird, and we still don't know what to do with that. And also, another thing, we in Bolt, we heavily rely on eventual consistency tools. So we don't use a lot of difficult synchronous distributed transactions. We use pretty simple stuff instead. And one of architectural decision which was taken back long in the past was to make such a thing. Let's say we have some taxi driver, the ride is finished, we want to collect the money. So we put a row in database with state pending, then we try to actually charge money from the payment service provider, and then we want to update the state of this row to be completed. And in case if something goes wrong with payment service provider, we can then look for all rows in state pending, and then actually try to charge again. And the problem with that is that, like, of course, it's better architectural decision, like in the sense that if we have a piece of code which tries to take a global lock to do this manipulation with pending rows, it's not scalable. So it's pretty fair to be considered our technical debt. But what's bad about it, like we can't migrate from it like in a single, I don't know, in a single week. We can just erase the code and replace it with others. So we still rely on it, right? And what happened with that code is that it became many times slower. So it became like hundreds times slower. And for some parts of our system, it's really big difference. And we are not happy about that. However, it's of course our technical debt. So to conclude, what we've learned over the migration is like try to make the best load testing as you can. Like try to really reproduce the live load pattern, because, for example, our problems with concurrent issues, we could actually find it out earlier if we do the load testing better. And now the teams in both which try to migrate from MySQL to TiDB, they do it better than us. They also use a tool called PT Upgrade, which is configured by our SRE team to find out the possible stall queries before the migration. So like also just after the migration, the system might be extremely vulnerable. So just like what happened to us during the migration with the PSP outage and increased load, this can happen actually to any system which migrates. And you should be prepared for such a case by, for example, knowing the possible optimization hints which are provided by TiDB. That's all. Thanks for attention.
By the way, where did you get that 99% delay of qualified? TiDB somehow providing that itself.
Yes, it is. But also, like for some graphs which I've shown, it was based on internal tooling of both. So it's also present in TiDB as well. No, our internal.
Because I think MySQL, MariaDB, you don't have like a ready metric I haven't found that tells that what is your 999 or 99.9% query times. Yeah, so there is this query times booking, but it doesn't really tell you have to somehow. I'm just trying to find out how to use that to calculate. I'm looking that they will have to use something. That would be to do it because I'm rather interested. I have been interested, especially now when there was like Black Friday. I didn't have that, or that would have been very interesting. The original reasons why did you get out of Vitess?
I think most of them are actually, okay, Boris, please correct me if I'm wrong. Most of them are organizational, in the sense that it was, okay.
No. Actually, the problem of Vitess is that it still has MySQL inside with all things that MySQL bad with. Like it's single master, it's very hard to scale, it's very hard to reshard. Application should know about sharding in case of Vitess and so on. And it's also not organizational, but like some additional management cost that you need to maintain, like some additional things for Vitess, like VT-gate, user management is different compared to MySQL and so on. So yeah, that's the most reason why actually we switched from Vitess.
Like basically how you create tables and SQL, some stuff is different there.
Yes. Yeah.
Hello, my name is Saulo, and I'm here together with Lucian, and we come from a company named Irori, all the way around all the way next door, sorry, from Stockholm, Sweden. And we're gonna talk a little bit about secondary ops for Kafka. I've talked to some of you about Kafka, but I just want to maybe get like a wave or something if you actually have heard about Kafka before. Right? Some, yeah, mostly. Okay, cool. That's good. Right, I'm going to do a bit of an agenda first. So I'm going to go through a bit of an introduction, a bit about what Irori does, and also together with Aiven, I'm going to describe a bit about Kafka high level, not going into super detail about it, because then I will be here and tomorrow if I would do that actually. Also some Kafka drivers, and then Lucian is going to take over and do some Kafka platform automation. And this is for you who want to run Kafka organization-wide, use Kafka but not maintain it, make development teams independent, and also sleep at night, which for operations teams are a bit, like that. Yeah, just a bit about our offerings. Irori doesn't do only Kafka stuff. We do platform as well. DevOps is great, but I don't think single person can ace the whole stack, really. I've been into that myself. We offer, this is a kind of a smorgasbord about our different pickings, about what we offer. We are big into development experience as well. And we help team with the cloud initiative as well. All right, so back to Kafka. So this is kind of a 4 layering here. We do have the runtime down here, StreamC, native. Of course, we have the hosted Aiven. I think it's called Aiven for Kafka. I got the nod over there. Great. So we have the layer over here, which is manage. Lucian is going to go into a bit of depth into that one. So we'll just skip that one a bit. And the streaming data establishment, which is it's called there, it's a bit about the building around Kafka. You need to have messaging, you have stream processing, event-driven architecture, schema registry, and all that, Kafka Connect, all those different things around Kafka. It's huge ecosystem, right? And of course, when things go bad or not as we want, to have Kafka support, which Aiven also has, of course. Right, so this will be more about the topic of today. Self-service, observability, security, disaster recovery, data governance. Together, if you would want to run Aiven for Kafka. I mean, yeah, I think that's cool for now. So just this is a bit of a lot of text in one slide. I know, apologize, but I think I'm going to share the definition for Apache Kafka. This is straight from their webpage. So let me read it to you, so you don't have to. Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipelines, streaming, analytics, data integration, and mission critical applications. Okay, that was a lot. And now, simply put, this is why I love Aiven. They're just like explain Kafka to me as a dummy. And they say, or simply put, it is a platform to handle transportation of messages across your multiple systems, multiple microservices, or any other working module. And this is very simplified event flow. So this is pretty much what Kafka does. You have a concept of producers and consumers, which are clients. You have in the middle, then you will have a Kafka cluster. And yeah, of course, you have topics, which store the data. But this is the gist of it, right? You send messages, and they come at the other end. Not that super difficult, I think. I have one one example actually. One of the biggest, our customers, is one of the biggest grocery stores in Sweden, uses Kafka as their in the transactions. So if you want to buy a 6-pack of eggs with milk, you actually blip the card. The transaction goes from a producer, goes to the message, and then it goes to Ivra. I don't know if you heard about it. It's kind of big in Sweden. I know it's in Finland, but it's kind of a email box for your identity, pretty much. And then you get a notification in your phone, and that's a receipt. So instead of having the receipt in your hand and in paper, which is not maybe the best for the environment, you do have it directly in your phone. So that means that it needs to be highly available, needs to be fast, and yeah, you don't want to wait like a day and see if you actually bought the eggs and the milk. Right, so let's talk a bit about Kafka drivers. Except for maybe us and Aiven in the room, developers love Kafka. I mean, I joke around, say that developers are lazy. We don't do a lot of testing. We don't do a lot of documentation. Of course, that's not true. Sometimes do. But Kafka is really easy if you do think about, yeah, I need to have this thing here, communicate with that, like an integration part or like an event which you sent, right? Something has changed. I need to notify the other application. Love it. Simply, right? You just send a message. Architects love Kafka. I mean, most of the use cases in the different companies I've been to, they either have an organization-wide Kafka cluster. That means that you have this subset of teams which all interact with Kafka, sending messages across to different teams in the organization. It's also, event-driven and all that good stuff, right? But then we come to the operation. It's really easy starting a cluster. You just run it up, deploy, and it goes on, right? But what happens when you need to scale? When more applications come and joins? Do they create their own topics? Or, you need to have some center of excellence, maybe, if you really want to run Kafka for real. I've seen many cases of when this has gone wrong. I've been doing some ops for Kafka for about 3 years, and I've seen all kinds of things. Observability, logging is really big into Kafka. You can have if you don't have quotas, you can actually have one application. Let's say you have 900 microservices. You have one application which could take down the whole cluster, right? And I've actually seen that almost happen, which was really scary. But we just, in the nick of time, we could mitigate that. The disk was, I think, like 93% full. And then maybe if you have the DevOps, where does DevOps fit in here? It's a mixture, I would say. It's a love and hate relationship, maybe. Who knows? But that's that aspect. Yep. And that's about it for me, hope. Yeah, and Lucian, there you go.
Thank you. All right, so we did a show of hands of which one of you have heard of Kafka before, but who here is running Kafka in production today? Do we have anyone? All right, nice. I'm going to go into some details about platform automation, and even though these are tailored towards Kafka, I hope all of you can get some value of it, because these concepts apply to different platforms and different tools as well. So first, I'm going to talk a bit about self-service and the whole concept of self-service, which can kind of be defined as whenever you specify something, you also define it. So basically, as a developer, instead of raising a ticket to operations, you actually fix the code yourself. This way, we minimize handovers and we get rid of the bottlenecks. And this image there is a good representation of the difference between developers and ops people. The developers want the candy and they want it now, and ops are tired of just solving tickets and fixing these small tasks. So ideally, with self-service, we can go from that to this, where developers get to enjoy their candy and ops can focus on putting off fires in other places. So how do we implement self-service? I would start by the first step being in the beginning. When you configure the cluster, you need to make sure that the configuration is easy to understand. You need to do your best to separate the concerns. And we recommend that you use the same configuration for all of the environments so that it's easier to identify issues the moment they arise. And when it comes to storing this configuration, where should you put it? Well, we recommend using Git because of a few reasons. Number one is that if you let this, you can let this tool handle the permissions, so who's allowed to do what, to change what. It represents a single source of truth, and it also has an audit log of changes, so you can see who provided what. Moving on to the orchestration here. We define orchestration basically as the realization of configuration. So how do we actually get this into our environment? And the configuration is owned and managed by developers, and it can be structured for different stakeholders. In addition to the simple orchestration, here we have these templates in the image, which we recommend to have in order to be able to decouple the feature realization from the configuration. So in most of our clients, we have a platform team, or at least a few people that act as a platform team who are in charge of putting together these templates and managing all the complexity that developers shouldn't be worrying about. And then in the image there, we have some orchestration tools like Helm, Argo CD. And yeah, in the ops side, the runtime environment, we can and we have been running it on Aiven with some clients. Bear with me, I'm sorry for a big diagram. Here we just want to show the high level of infrastructure, where we have the platform team, like I mentioned, creating and maintaining the Helm charts or different kinds of charts and templates that both the developers and the operation team can edit, or not edit the templates, but fill in the templates and push that code into Git. That can then be read by, for example, the Aiven operator for Kubernetes and deployed in the runtime. And I'm going to stop here for a second and mention that this configuration is not just I'm creating a new topic or a consumer group. This configuration should also apply for different kinds of tools, such as monitoring or alerting and other stuff. And our recommendation is to use the configuration for those tools in the same way. So you would start by defining it in the Git repo, and then the operator can deploy it. The next concept, observability, I'm going to split it into two. We have monitoring and alerting. In terms of monitoring, there's a bunch of different logs that come out of the box for Kubernetes and for Kafka. And we use these to create different dashboards that can be interpreted by various different stakeholders. So for example, we use these dashboards for ops people so that they can monitor something during a change, or they can track back to what happened in an incident and so on. And yeah, developers, they can see the performance change, or they can see what optimizations have been done after a change as well. The second one, alerts. We usually classify them into three different categories. Number one, the most common, the shit hit the fan incidents. These are, a lot of the alerts are already built in. We like to think of these incidents or alerts as it's a bit too late, but here's what you kind of need to do. So we recommend to change the focus towards the proactive alerts, to be prepared and to have a clue about something before it's too late. And then, of course, governance alerts for enforcing rules such as storage estimates or consumer group lags and so on. Yes, The next big concept is disaster recovery. And for those of you who know a bit about Kafka, you might be saying, okay, but Kafka has redundancy. Why would we need disaster recovery? Well, we have some layer 8 problems every now and then where someone, a chaos monkey, does something to your cluster which can't be fixed by just the Kafka built-in properties. I'm going to start by saying what we should not do. These are 3 approaches that we reject or not recommend. Number 1, taking disk snapshots. We don't recommend this because if you're taking them every day, you lose all your live messages. So you have some lost messages. And if you want to take these snapshots every hour, they become quite expensive when the cluster is quite large. Then the second one, having 2 Kafka clusters in an active-active configuration. In case one fails, you probably deploy them in different availability zones, etc. We don't recommend this because every producer or consumer that has this configuration will have increased complexity of being able to connect to both clusters. And this adds quite a few issues, and it makes it complex plus expensive to maintain 2 clusters at the same time. Well, then how about flushing the messages to S3 or a blob storage? We try to stay away from this because it basically takes the data outside of Kafka, and it adds so much complexity, and it's not Kafka anymore if you move all data in blob storage. So what do we do recommend? We recommend having a passive mirror cluster. We keep this cluster small, so we have like 1 replica for all of the services. And we do this using Mirror Maker. And yeah, of course, don't provision it with the same tool, because in case you have a problem via Argo CD, you don't want to have the same in the mirror cluster. And then you can also add alerts and self-checks in it. We, in my client right now, we have had a chaos monkey, unintentional chaos monkey, that allowed us to test our disaster recovery in one of our environments, which went quite well. And it showed us that if this were to actually happen in production, we would have a very small downtime. Yeah. Then I have a few words about governance and sort of wrapping these concepts together. Deciding on the rules to follow is easy, but actually maintaining them is the hard part. So everyone's sort of a bit scared of self-service because they think we're going to reach this wild, wild west situation where everyone's sort of pointing fingers at each other and no one knows what's going on. But if you spend enough effort in the beginning to force developers to make decisions early and make good decisions, and then you also set up some automation tools to validate the configurations and generate alerts from the configuration that they deploy, this can be a very, very good place to be in with self-service. Yeah, I think I zoomed through this quite fast, but I want to say, first of all, big thank you for Aiven for having us here. And I hope that you guys managed to take at least one thing from our presentation and apply it to your toolset. Yep. Thank you. Is there any questions? Yes? Yes.
How actually the recovery starts? When you have like, okay, you have one.
Yeah.
But how you?
Yeah. I can give the example of my my assignment right now, which I work in a retailer company in Sweden, where we have a bunch of transactions and our cluster is quite large. The way we interact with the cluster is through a DNS that points to we have it a green-blue cluster. So normally the DNS points to the blue cluster, which is scaled up. And then in case something goes wrong with that, we use Mirror Maker to scale up the other cluster, the green one, and change the DNS to point to that one. So basically, we're redirecting traffic to the new cluster and scale it up. Does that sort of answer your question?
Yeah, but why the second cluster will not die? Like first.
Yeah. So we assume that disaster recovery or this disaster recovery strategy goes into place to solve layer 8 problems. So when someone deploys some bad configuration or someone removes a template and deploys that without it. So that's why we mentioned here to not provision this mirror cluster with Argo CD so that that problem does not happen in the other cluster as well.
Yeah, that's one point. Actually, right, another question.
Yeah.
It increased complexity in my opinion because you have to maintain two provisions.
I agree with you. We use Mirror Maker for this, which is quite helpful in keeping offsets in sync and making sure that the passive cluster is ready to go. But there isn't a very, very simple and easy answer to disaster recovery, and we found this to be the, I wouldn't say lesser evil, but the easiest thing to maintain and deploy for our clients. Anyone else? Yeah. Yeah. Sometimes on purpose, sometimes not. We do. We don't do it at a big level in big clusters, but in lower environments we do. At my client, at least. I don't know if maybe Saulo has some other stories from. Yeah. We in my company we had a penetration tester trying to do that, and luckily he failed because of permissions. But we are every now and then doing it without wanting to do it. Mm. 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 Yeah, that sounds really interesting. Cool. Anyone else? Yes. Mm-hmm.
All these changes are replicated.
That's a good question. I guess problems that arise at a later time don't necessarily fall into the disaster category, right? It's I'm struggling to find an actual example of when this would happen. Do you have a scenario in mind or just like a concept? Yeah. So I think that as long as we manage to deploy the change and it doesn't immediately break the system, after a while with a delay and making sure everything's fine, we would also provision the mirror cluster with the same change. So if there would be a problem that would arise after that interval, I don't know. I don't. Yeah. Yeah. Yeah, it's really nice. I would also like to mention that if you go on our website, you can read a bit more about our, we have a few videos where we describe the different projects that we have together with our clients. And we also started to spend some time developing some open source tools that can solve different limitations of Kafka, so to say. So, yeah. And please feel free to come speak with me or Saulo afterwards and maybe even have a drink after. Yeah, thank you.